Hi everybody, welcome to lesson number 6 of our measurement unit. Today we're going to be looking at, again, conversions, but this time we're going to be dealing with area and volume. So we're no longer just doing one-dimensional analysis. We're going to jump into some 2 and 3 dimensions here. Okay, so the first part, as always, okay, I would like you to do on your own here. So where it says investigation here, and the first thing you're going to be doing is converting in the units of area. And then again, that's within the metric system. So go ahead, pause the video, and run through a few of these steps here so you can get the idea of what's going on. Okay, we're basically looking at area, and that involves 2 dimensions, of course. So it's a little bit different than just converting length, which is in 1 dimension. But anyway, go ahead and read through that and follow all the steps. And I will go ahead and jump right to the example number 1. So here we go. We're going to convert 12 meters squared to millimeters squared. So again, we're looking at area now. So it's no longer just 12 meters, it's 12 meters squared, which is a lot different than just 12 meters. Okay, for example, if I were to do a little diagram down here, okay, 12 meters would be just a linear distance, maybe like this, 12 meters, which would convert to, well, 12 meters, and how many millimeters in a meter? There's 1,000, so that would be 12,000 millimeters would fit into 12 meters. And again, if you don't know that conversion, you can go to centimeters, and then from centimeters to meters. However, when we're doing working in 2 dimensions, 12 meters squared looks something like this. I'll give you an example. It could be a rectangle that is maybe 4 meters by 3 meters, and that's going to give you basically 12 square meters. If we look at this, if each one of these is 1 meter squared, now there's 12 squares, so that's 12 square meters. Now, how do we convert this to millimeters squared? Well, it's going to be a little bit different than just going multiplying each of these, multiplying these together to get 12 and then converting it using this, because it's because again, we're dealing with area. There's a lot more millimeters that are going to be involved in here. Okay, it's going to take many more millimeters, squared millimeters, to cover this area here than it is just to cover this line. So as you're going to see in a second, this is how we're going to do this. Okay, so again, 12 meters squared is the thing we start with, and we want to end up with millimeters squared. And the conversion, like I said, is going to be for every meter, and remember we put the meters on the bottom, there is for every 1 meter. Now here we go, watch this, there's going to be 1,000 millimeters. However, because we're dealing with square units, it's not really 1 meter, it's 1 meter squared. And then how many millimeters squared that is? Well, all we do is we just square the 1,000 to get how many squared millimeters are in a squared meter. Okay, so let's go ahead and make that conversion. So really, we're multiplying. It's going to be a much larger number here, as you're going to see in a second. So 12. It's going to be 12 times 1,000 squared, which again is a million. Okay, so now we end up with 12 million, I should say. I believe 1, 2, 3, 1, 2, 3. Yeah, so this was 12 million millimeters squared. And that seems like an awfully large number there. Okay, but when we actually think about it, let's go ahead and well, I guess you've done some of this up here, but just a quick example here. Okay, in 1 meter squared, which is just like this. Okay, 1 meter squared. Okay, 1 meter squared. All right, that's again 1 meter by 1 meter. Well, in 1 meter, there are 100 centimeters. Okay, but in 1 meter squared, there's going to be 10,000 centimeters squared, because we're squaring the 100. And let me just show you how that works. Okay, if I converted this, let me do it in red here. If I converted the 1 meter to 100 centimeters and converted this 1 meter to centimeters, then 100 times 100 is going to give us, well, if we kind of look at it, if I were to divide this into 100 sections, obviously this isn't very accurate, and then did that this way, you would see that if you counted all those squares up, if I actually did this properly, you would get 10,000 squares, little centimeter squares. So it's a little bit hard to get your head around at first, but it is quite a large area, and converting in area is a little bit different. Okay, enough of this. Okay, I'm sure you've done this investigation here, so hopefully you get the idea. Okay, same thing here. We're gonna go 40. Let me do it in green here. So where am I here? There we go. 41,500 centimeters squared, and we want to get to kilometers. Let me leave some space there for the actual number. Kilometers squared. Now we're going back the other way, so it's going to take a lot less kilometers to cover that many centimeters. Remember, a centimeter squared is about the area of your pinky fingernail. Okay, so it's not a very big area, so it's not, so basically we have 41,000 of your little fingernails. Sounds kind of gross. Sorry. Spread around the floor, and we're going to see how much area we can cover. I bet you we're not going to cover a lot. Okay. So let's go ahead and do our conversion. Our conversion would be, again, start with this. Start centimeters on the bottom and kilometers on top, because that's what we're dealing with here. So 1 kilometer. 1 kilometer is going to be 100 centimeters in 1 meter, and 100 meters in a kilometer. So that's going to be 100 times 100, which is 10,000. Or sorry, rather 1,000. 100 times 1,000. So the 100 because there's 100 centimeters in the meter, and then 1,000 because there are 1,000 meters in a kilometer. So I'm kind of skipping this all in one go here just to get this conversion. So that is going to be a 100,000. So 100,000 like this. Okay, so 100,000 centimeters fit into a kilometer. Again, however, because we're dealing with units of area, I'm going to have to square that conversion as well. So really, in the end, it's going to be 41,500 500 divided by 100,000 squared. Okay, and you will see this is not gonna it's going to be a very small number, as you can see there. 4.1, what was it, 4.15 times 10 to the negative 6. So that is again, that is a really small number, and it's not even I don't even think it would cover a meter of area. Okay, all right. Well, actually, it wouldn't, because it takes as we look down here, it takes 100,000. It takes 10,000 centimeters to cover 1 meter, and we have 41,000 here, so it would cover about 4 meters and a bit. So nowhere near a kilometer, right? You're looking at the area of maybe a classroom that would fit all those little fingernails. Okay, all right. Now we're going to look at volume within the metric system. Now we're dealing with 3 dimensions. So again, go ahead and read this investigation, and hopefully you'll see why we need to cube our conversion rate now when we do our conversions here. So go ahead, pause the video, and get back here in a second. Okay. We have we're converting meters to millimeters. Okay, and again, now we're looking at 3 dimensions. So this is almost quite a large amount of space here, meters cubed. and how many little millimeters. Now we're looking at little cubes, so it's no longer your fingernail. Now we're looking at your entire tip of your finger. Okay, if you were to visualize this in 3 dimensions. So 26 meters cubed would again, start with your set up your equation here to match everything up here. So again, the conversion rate for 1 meter to get into a millimeter, well, again, there's 100 centimeters. So there's 10 millimeters in a centimeter and 100 centimeters in a meter. So we're going to multiply 10 times 100 times 100 to get 100,000. Sorry, 1,000 there to get the millimeters. So there's 1,000 millimeters in a meter. But again, the key difference here is that we're in cubed units, so we have to, we need cubed units, and that conversion, we're going to have to cube that 1,000. So now we're really looking at quite a few millimeters cubed to get to 26 meters cubed. So it's going to be 26 times 1,000 cubed. Okay, so what we're looking at quite a large number here, as you can see, 2.6 times 10 to the 10, I believe it was. Yeah, 10 to the 10. Okay. All right. So again, let me just I'm gonna go ahead and you guys can finish this. I'm gonna do a couple more down here. Again, we're looking at inches down here in terms of area and feet as well. And basically, again, read all these investigations. All these examples are similar. Okay, now we're just looking at imperial units. So I think you can go ahead and do that. Same thing with volume and imperial units. So read that investigation. I'm going to just conclude with one final example that I think I will do right here. So let's say you're ordering some pizza right now. Now pizzas come in. When you go to get a pizza, they're gonna say, if you ask how big is a small pizza, they're gonna say, well, maybe that small pizza is 12 inches. Now, what does that 12 inches measure? Well, that 12 inches measures the diameter of the pizza. All right, and let's say that pizza cost maybe cost $15. Okay, so I'll say it costs $15 for the small pizza. Okay, now let's say here we have a large pizza, and the large pizza. Okay, the diameter of the large pizza would be let's say 18 inches, and that would cost $30. Okay, so we have $30 for the large pizza and $15 for the small pizza. So now here's kind of the typical question you might get. If you're ordering some pizza for a party, well, are you going to get one large pizza or are you going to get 2 smalls? And most people would kind of look at this and be like, well, of course I'm going to get 2 smalls, because if I get 2 small pizzas, that's going to be 24 inches worth of pizza, and that's going to be $30, and that gives you the same, gives you more than the 18 inches for the same price, which is 30 for the large ones. You might go for 2 smalls as opposed to getting one large here. However, if we look at some of this from what we just learned, you're going to realize that the large pizza is a much better value. Okay, the large pizza is a much better value, and here's why. Okay, well, the simple reason is most people do not get a pizza and start biting it down the middle like this and then throw the rest of it away. Okay, if that was the case, then yeah, 2 small pizzas would be a better deal. Okay, most people eat the entire pizza. Okay, which is the measurement of area. Okay, you're more interested in the area of the pizza than of course you are the diameter. Okay, which doesn't make a lot of sense. Okay, so what we really need to calculate is the diameter of the pizza and the area of the pizza, and then compare that to the price. So if a pizza is a circle, okay, and most pizzas are a circle, the area of the pizza would be pi r squared, okay. And if any of you end up going to UBC, there's a pizza shop there that sells pizza called pi r squared, and this is kind of the reason, okay. So pi r squared here we have, that's pi times the radius squared, so we have pi, and then the large pizza would be 9 squared, so 81 or 81 pi. And the small pizza here, I'll do it over here. The small pizza would be, well, the radius is 6, so 6 squared is 36 pi. Okay, I don't need to do the pi because that's the pi is the same in both questions. Okay, well, again, I'm gonna double this now because I have two small pizzas. Okay, I have two small pizzas, 12 inches, and that's gonna give me 72 pi. And again, that's going to be inches, squared inches, okay? And again, this is going to be squared, let me just write it out here, inches squared, inches squared. Okay, all right, now what we're looking at here, we see that the large pizza, even though it's only one pizza, actually has more area than the two small pizzas combined together. So now when we look at it this way, it seems, or it looks like, it is the large pizza that is the better deal for $30 than the two small pizzas for $30, because you get a little more out of the area, okay? And again, that's one of those things that when we're converting in areas, it's a little bit different than just doing it linearly, okay? Last thing I'm going to end up with, of course, not every pizza, I mean, especially if you're going into Chicago and you're getting some of those deep dish pizzas, you're gonna get a pizza that is also not quite two-dimensional. Most pizzas have some thickness to them, unless you go into those Italian places and getting the real thin crust. You're gonna get some depth to that pizza. So most pizzas are gonna look like this, right? They're gonna have some, this is from a side angle. They're gonna be a little thick, okay, especially those deep dish ones. And let's say that thickness is 1.5 inches. Well, now when we're doing this, now we're actually going to measure the volume of the pizza, and you're going to see basically what you're going to see here is that when we take volume into account, okay, the third dimension of this height here, okay, you're actually going to get even a much more better deal for the large one than the two smalls, okay? So anyway, that's a little side note there on those three different obviously three different ways of looking at things. So it's not always measuring things linearly might not always be the best bet. So again, go through all these investigations. I think that's kind of going to be the best way. You're going to solidify these concepts just doing them on your own. Okay, thanks for watching, guys, and see you next time.